Hello and welcome everybody to another webinar of Data Minded. It's a webinar today to bring you from from notebook hell to container heaven, why your code deserves a better environment. I hope everybody can hear me all right. If you can you put in the chat that the sound and everything and audio, video is all good? I am Chris, I'm the founder and CEO of Data Minded, and I have a remote guest with me today. His name is Pierre. Pierre, can you also quickly introduce yourself?
Yes, hello everyone, welcome to this webinar. I'm Pierre, I'm a data engineer at Data Minded. I mostly work on DataFi, which is our data platform, which we'll briefly touch upon at the end of this talk.
All right, cool. So yeah, we only have half an hour. So Pierre, I suggest let's dive in. You can share your screen. And for the audience, if you have questions, leave them in the chat. We're reading them and we'll handle them at the end. Also, there's handouts. There's a handout link where you can see the slides for yourself. All right, we've done the presentation. So if we go to the introduction, maybe first, why are we doing this, right? We see quite a lot of clients. When we go to that client, their front end looks really amazing, looks quite cool, the tool they use, but then when you look at the back end, very often it's nothing more than a production system that is duct taped together by a bunch of Jupyter notebooks, and then they ask us for help, like, what should we do? Can you fix the notebooks? And usually by that time it's way too late for a fix, right? And it's more a rewrite is appropriate. And the difficult thing is that you only realize late when you're in production that you've arrived in this notebook hell. You don't realize it when you're developing. So today we want to show you an alternative. What can you do as an alternative to that? So if you look a bit at the agenda or as the structure here, today is going to be the first part of the webinar where we're going to bring you from notebook hell to container heaven. So we make sure that your code ends up in a container on your machine. And then the second webinar in 2 weeks is about, okay, my code is working on my machine, that's great, but now can I make it work everywhere else, in the cloud or on premise, wherever. And then finally, when you are able to schedule containers in the cloud, then how can you do this at scale? So how can you ensure smooth sailing through orchestration, basically? We want to wrap it up with a hackathon right here in the office in Leuven, where we can what we see today, we're going to do very hands-on in the hackathon. So we're all going to start from a notebook and move it to a container, move it to the cloud, orchestrate it. It's a bit of a question mark if we can do it here in the office or if we're going to do it through remotely. It all depends on the big virus that is still with us and changes in rules that happen from week to week. So we'll see if we can do it in the office, else we'll do it online. All right, with that, I think I've said my most useful things. The actual content and intelligence today comes from Pierre. So I would say, Pierre, you can have a go at it.
Thanks, Case. So the first thing I would like to say is that, like notebooks are great. We don't love or hate them, but that's actually the start of this. Notebooks are often a love-hate affair. It really depends on who you ask. And so, for instance, this is a very famous talk. I recommend you watch it, from this guy, Joel Gruss, who's explaining why he doesn't like notebooks at great length. And of course, as with everyone on the internet, you have the response to that, which is this other talk by Jeremy Howard saying why he does like notebooks. And it's really interesting to see the response. More globally, recently there was a study published where a bunch of notebooks were analyzed to see what were the quality issues and the reproducibility issues. So that's quite interesting to look at. And finally, this here is a tool set by Jeremy Howard, so the guy on the talk above, who explains how all the pitfalls can be addressed with this tool. And so I recommend you look at this if you want to address some of those. That being said, let me quickly highlight what we do see often, and those are opinions, but what we see is typically notebooks shine for this, obviously, like quick iterations and tight feedback loops. So here you can see someone investigating some data set and is using, interestingly enough, is using Python, but also SQL. You can also write some Markdown in here. So it's really a nice way to get a feel for your data. In the same vein, it's really usually a good tool to get very early data exploration and visualization. So here we have a bunch of visualization, and this helps you really get a sense of what you're dealing with and what you could build as use cases on top of your data. And then I also need to mention machine learning. So when you build machine learning models, you have all the cycle you have to go through, right? Identify use case, assess your data, define your MVP, etc., until you actually deploy to production. And in the step 2, where you want to assess your data and see what you could build, this is really where, in our opinion, a notebook can shine. So this is where they're good for. So what are the issues then? Well, we think that notebooks typically lack for those problems. First, what do you do with secrets? So you typically need to access APIs or access data on S3 or something. What do you do with your secrets? Modularization. Typically, notebooks are get to the point quickly, as quick as possible, but it's not so great about reusing code and organizing your code. Next is a big one too, is how do you test a notebook? And yes, there are tools for that, but it's not what we see typically. We see people not testing their code in notebooks. And the biggest one of all, probably for me at least, is reproducibility, meaning how many times have you checked someone else's notebook and been able to actually use it from the first time directly without any issues? Me, it's probably 0. So, and the reason why is like typically, okay, which Python version was used? What are the dependencies that you're using? You have hard-coded paths in your notebook. Typically, you have configuration that depend on the environment you want to run in, like development or production. The order of execution of cells, that's really nice that you have this interactive reflow in a notebook, but as another person, I don't know in which order I'm supposed to execute the cells, which also leads to typically hidden state in your notebook. So all of that together makes it really hard for you to give your notebook to someone else and just say, yes, it's going to work for you. And then also very important to us is versioning and collaboration. What do you do with your many versions of your notebooks, and how do you collaborate? So yes, you can put your notebook in a version system like Git, but notebooks are just JSON files, and they're notably very difficult to inspect for diffs. So that being said, let's have a look at our use case for today. And since Chris has been teasing this webinar with ships and containers, it was only fitting that we talk about a big boat. So here's the Titanic. And this is what I'm going to present for the sake of time here in this webinar is a stripped down version of this full notebook here, which was taken from the Kaggle competition. And the basic idea is to look at as input as a list of passengers of the Titanic and see some of their characteristics, and we know if they survived or if they died. And now we would like to predict for a new passenger, it could be a real one or a fake one, and we would like to decide if he's gonna survive or most likely die. And so I won't go into, so this is just to show you that it's not a big notebook, so it's small enough. So instead of going through all the code here, I prepared the next slide, which is more visual, which is exactly explaining what this notebook is doing. So the first thing it's doing is loading the training data set, and you can see it's just like passenger ID, did that passenger survive or not, in which class was he traveling, the name, the gender, the age, and so on. And so that is the training set. What we do from this in the notebook is we extract some features. So typically the age seems to be relevant. The class also was relevant. The size of the family was relevant. So we extract those as features. And then the target of the model is, of course, to decide 0 means the person didn't survive and 1 means they survived. Then we train what is called a classifier with this, and the details don't matter in the context of this presentation. Just know that at the end of this, we have a classifier that is able to answer the question, would that person be likely to survive or not? So now we can apply this classifier to a test data set. So imagine we have new passengers here, and we don't know if they survived or not. We just know their characteristics. We interrogate the classifier and we get predictions. So the output of the notebook is prediction for those new passengers, saying each passenger yes or no that survives. And the notebook takes the input data from an S3 bucket and writes the output to S3. So I hope that makes sense. It's a small enough use case to demonstrate what we're talking about here, which is how can we bring this notebook to production. So in order to do that, this talk is about bringing your notebook to containers. So let me briefly introduce containers, very high level. We're not going to go into details, but if anyone is not familiar yet with containers, it's good to start with, what is a container? So for that, I have this comic here, which is a nice explanation. So let's say you created an application and it's working just fine on your machine, so you're happy, yeah. But of course, as always, it doesn't work in production, and you don't know why, right? And so this is where the famous words come, like, it works on my machine. So what do we need? Well, we need a standardized way to package your application with everything, dependencies and everything, and to deploy it to an environment. And here it's mentioned Docker, but really I should mention containers in general. Docker is just one specialized version of containers, but containers are, a generic tool, and they're designed to make exactly this. So how does a container work? It packages your application and all the dependencies in a virtual container that you can run anywhere on Linux. And a little bit more in detail, you can think of a container as a very lightweight virtual machine. So it takes less space, it's isolated from the rest, but it's conceptually almost identical to a very lightweight virtual machine. So with that out of the way, we know what is a container, okay, but which problems do they solve? Well, I highlighted 3 here. The first one is reproducibility. Why? Because as we'll see, the way you build a container is by describing your infrastructure and your dependencies as code. And so this is completely reproducible. You can give that file to someone else and you can build exactly the same container or image. And also this can be put in Git, so you can version everything. So it's part of your code. The second part, big one, is portability. So it's the famous build once, run anywhere, but this time it's kind of true. So there's no more gap between development and production. You build your image, you can ship it anywhere on Linux. And then finally, and this is also very important, in a big company where you have many developers, you used to see a lot of, okay, this is our standard tech stack. You need to use, I don't know, Java, Scala, Python, this version, those libraries, because that's how we equip our machines in production. Well, with containers, you can alleviate this, because you can say to each team, you can empower them to say, you can use whatever you want, but you are responsible to ship all that you're using in your containers. And so you can really empower your developers. So that's all very high level. What does it look like concretely? Well, the 3 important concepts to know are this. So in a Docker file, and we will see a concrete example, you describe as code your container, everything that will be inside, the dependencies and your code. From that, you build what is called a Docker image, which is not running yet. It's just think of it as a binary representing your project. And then running, when you run an image, it becomes a container, and that you can run anywhere, again, where you have Linux installed and Docker, or any container runtime. So a Docker file, what does it look like typically? Well, it's a declarative thing where you say, okay, from this base image, so in this case, it's a Node.js, so this is a typical small JavaScript application. We start from this. We will run some command inside of it to install what we need, our dependencies. We will say how we need to run the application, and that's it, basically. And so this is a very simplified Docker file for a very simple project, but you get the idea. So you declare what you need, and with that, this is completely self-sustained. You build your image, and it's going to be able to run with no difference between development and production. A small interesting detail about Docker or containers is that they build in layers. So each instruction here from top to bottom is here from bottom to top. And that means they build like a lasagna layer by layer. And for instance, if you look at your code where we're going to copy your code, is this just before the last command. So if you were to change your code, we only need to rebuild that layer 6 and that layer 7. So that's an optimization that is very useful. We don't need to rebuild the whole image every time. Okay, so I hope that gave a clear overview of what containers are. Let's get a bit more concrete. But first, let's get back to our use case. So you remember that is our notebook. So again, without looking too much into the details, we are importing some dependencies, we're loading the details, we're adding some features to our model, we're training our model, and then we're applying our model for prediction. So I'll just leave you like, I don't know, 15 seconds to try to identify what you would think are mistakes or issues with this notebook. And then I'll show what I think are the biggest problems with this notebook. Yes, I see some answers in the chat. So plain text access keys, yes, definitely. What else? All the imports, in what sense? Yes, absolute file paths, absolutely. Package versions, yes, that's yes. So that's pretty good. You code like most of them. So indeed, the imports, they're not versions. So I don't know which versions are compatible together, especially like sklearn with pandas and all those stuff. So of course it's gonna work right now, but 6 months down the road, someone is gonna try this and it's not gonna work. Next thing is I blurred them out, but you can imagine here you have my Amazon access keys to access S3. So that's a big no-no, especially if you share your notebook or put it on Git. The next one is hard-coded path. Indeed, we have a full path to your training set. So what if I want to run the same thing with different data? Then here I have some code with some logic and, hopefully it works, but it's not tested. So lack of test. Here we say, hey, we're going to do the same data preparation for the testing set as with the training set. So repetition of code. So that's clearly a flag for, hey, we should modularize this and create functions, which you can do in notebooks, but typically you don't see that much. And again, hard-coded path. So this was just for the gimmick of the 7 mistakes game, but you get the idea. So what we're going to do now is actually take this notebook and step by step bring it to a reasonable level of production readiness. So first, I would like to make a statement that we believe in at DataMinet is that data products benefit from the same software development best practices as software developers usually do. And if you're interested into that, we have a previous webinar where we presented our data engineering manifesto, and it's basically a set of beliefs that we adhere to, where we say one of those is exactly this, that we should follow software development best practices. Now, for our notebook to be production ready, our code should be versioned, so that's quite obvious. It should be reproducible. It should be well organized. We'll do a reasonable effort in the time frame of this demonstration here, and it should be somewhat tested. And what we aim to achieve at the end of this conversion from notebook to production ready code is we should be able to run this Titanic survival prediction as a container. We should be able to pass to this container which files we take as inputs and what are our secrets and where we want the output prediction to be written, and then check that indeed we get the predictions where we specified the output path. So let's work towards that now. I'm going to switch in demo mode. I do have backup slides for all of that if it doesn't work, but let's skip the slides and go to live demo, basically. So I hope you can still see everything correctly. Chris, you can just, yes, I think I see that in the screen sharing. So I just scaffolded. So the first thing to do, right, remember, is to version our code. So the first thing I did is put myself in a Git repository with nothing but my notebook. So if I open this in a code editor, it's easier. So I just have my notebook that you've already seen. So the exact same notebook, but in my editor. The only thing I did is remove my access key before I put anything in Git. So that's something you should always do. Never publish secrets to Git or any version system or any way of sharing your file. And then I just scaffolded the project, which means give it a structure. So just a source folder, very simple, a main file with nothing yet. And then the things I know that we will need. So the first thing is a setup.py, where basically it's the ID card of my project. I give a name to my project. I say, okay, I'm going to declare my dependencies in this file here. And that's basically it. And which version of Python I'm using. That
sounds very intimidating. When you see it, you can often copy paste it from somewhere else, right? So it's not that intimidating as it looks.
Yeah, so the scaffold I'm using here is very lightweight. It's something you can find in many open source examples. And I will also talk later about the fact that the tool we provide, Datafy, can also give you template that give you all of that for free. So it's basically just declaring what you want in your project, but there's nothing too complex. Then the next file that we have here, still empty, is the requirements.txt, where we will actually pinpoint our dependencies. And the Docker file is where we will explain how to build a container, an image for our project, and then run it as a container. So that's the step one. step 2, and I will check out my next commit in Git to show you. So indeed, we need to pinpoint our dependencies. So now this requirements file, I looked at my notebook, I looked at all the dependencies I was using, and I'm just declaring them with the exact version I want to use. I also check that those versions work together. So this is a bit of, what you can do typically is just install without the version, see what was installed. If it works, you look at which versions were installed and you just pinpoint them. So you're sure that this combination of dependencies work together. And you can go to the PyPy website to check which are the latest versions of every package and see how they work together. So that's about fixing dependencies. The next step is then to organize our code somewhat. And this is going to be probably the hardest to explain in a short amount of time. But so you remember how maybe let me share that actually. So where is my full screen? Sorry, I'm looking for my browser window. It's here. So here I have the same notebook as before. So basically, a few things we would like to do is not have the hard-coded path like this. Typically, what I like to do with code is whatever is input, output, and side effect in general, I like to keep that outside of the logic code so that you can test your code without having side effect, or as much as possible. If there is some logic, I would like to test. And if there is repetition, like here, we repeat everything that we've done here, I would like to put that in functions that I can test. So this is basically what we're doing. So if I look at the code, let me close that now. So I have a main file, and it's going to be very little logic in here. What I do is set up a logger parsing the arguments, because this is going to be a command line that takes those arguments. So in which bucket is your data? What is the training set? What is the list of new passengers that we want to test? And where do you want to output your predictions? So at least it becomes a nice command line tool where you can pass all the input output. So you can reuse it across multiple data sets. And then the next thing I do is just the main logic, which is going to be all the side effects are here. So loading data from S3, creating a predictor, and we'll get into that, and then do the prediction and save the prediction to S3. So all the side effects are here, meaning that all the logic that is actually about the core, the meat of your notebook will be in this class predictor, which we will look at now, and it's completely possible to test it. So if I look in the predictor, now predictor has two main functions, train and get prediction. And you can see those are the two only public functions that I have here and methods. And then what do I do here? Well, I get the data set and I compute, like we said in the picture earlier, we compute the features, the target, we train a classifier, and that's it. And the prediction is just doing the same, getting feature. So that's where we use the function and doing the prediction. And that's it. And then I have all these nice little functions like adding the gender feature, adding the age feature. And they're very small and completely, well, not without side effects because they manipulate the data frame, but at least I can test them in isolation. I give a dummy data frame and I see if the output is what I expect. So, which is exactly what we do in the next step. So if I look now, step 4, what I did here is add tests. So if you look at the test predictor, not going too much into the detail, but for instance, I'm testing this add gender feature. I create a dummy data frame with just this column with the gender male, male, female, male, male, and I'm just checking that the extraction of the feature, which converts this to 1 or 0, is actually correct. So this gives me confidence that this function is correct. So I feel much better now. And the same is true for any code that if you isolate the code enough in small functions, you can always do that easily. So for the sake of time, I won't go too much into detail about that. For step number 5 is finally, and this is very important. Okay, so what have we done? We have put our code nicely together. We have some tests. We have declared our dependencies here. Now it's time to build a container, right? So that's the Docker file. So like I said, what do you do in the Docker file? You give instructions to build an image, which you will be able to run. So the first thing we say is we start from an existing image because Docker containers images can be built on top of each other. So there's already a publicly available Python 3.9 version with everything I need for Python. Then I say, okay, we're going to work in this folder, I'm going to expose some environment variables. Then I'm going to make sure pip is up to date. And then finally here. So I'm copying this requirements file inside the container and the setup file, and I'm installing in all my dependencies. So now my image is equipped with all my dependencies. And I do this before copying my code, which I do here, because this typically you don't change much. You set up your requirements at the beginning of the project, and unless you are updating libraries, you don't need to do it anymore. And then finally, you install your code itself, your application, and you say, this is how I run it. And so this is like a recipe for your image, and we will see how we can run this. And when we run this, we have an image that we can run anywhere as a container. And so again, about those layers, if you change your source code, only those two things will be needed to run, because this didn't change, none of that changed, so only this will be rerun. So if I demo that now here, I'm going to clear my screen. So I do a Docker build in this folder, right? So I'm in the same folder with my Docker file here. So if I do Docker build of this folder, and I give it a name, a tag it's called, and the name I gave is Titanic Survival Prediction V1. If I do this, it's going to execute each of the comments that I have in my file, and you see it's 1, 2, 3, 4, 5 to 8 comments. It's exactly the comments I set. In this case, it was very fast because, as I explained, it's cached, so it was already done. So now we have a Docker image called this, and we can run it. So now the final step is going to be to run my code as a container, which I have a comment for, which is a bit long. So I have it prepared. Sorry. Docker run. Yeah. So what am I doing here? I'm doing Docker run of this image that we just built. And then I'm passing some environment variables. In this case, I'm passing my secrets. So yes, now is a good time to make a screenshot. And then with that, I'm saying, okay, I'm running this container and I'm going to pass those parameters. And those parameters are the parameters of my command line application. If you remember, in here we are parsing all those parameters here where we pass where is my data and so on. And so now if I do this, I have some data on S3. If I run this, this will take the image, run it as a container with those parameters, and hopefully succeed. So let's see. Yes, I see it's loading data from S3, the training and test set. It's extracting features, training classifier, predicting the survival, and here it's showing you some sample of it, and it's writing the data back to S3. And now if I also have a copy to show that this worked. So if I do a copy of that output file locally from S3, I should be able to see some data. So yes, this is the file I retrieved from S3. So our container worked. So it might not be very impressive. The notebook did the same thing, right? But now it's completely portable. So that Docker image I can share with anyone, and they can run it anywhere where they have Linux and a container runtime. Okay, so back to the slide, and we're almost finished because I see we are almost out of time. So all those slides are what I just explained in the demo. So that's all very good. And this was a short story, taking a notebook to an image and running it as a container. So what can you expect next? Just two things. First thing is, as I mentioned a few times, we at DataMinded are building a product called Datafy, which is helping exactly with those problems. So the goal is to deliver data products as code. Datafy is helping you building containers and deploying them. It's also helping you, and we'll talk about that in the third webinar, orchestrate your containers. And to some extent, it's also helping you with notebooks. So you can see here, we have a notebook inside of Datafy. It's someone owns that notebook. It belongs to a project, to an environment. And also it has some maximum idle time, meaning this is meant to be ephemeral. It will be killed after some time. So it's really just meant for exploration. And then finally, what can you expect from parts 2 and 3? So in part 2, we're going to see, hey, it works on my machine. How can I run this in the cloud? And in part 3, we're going to see how we can orchestrate all of that, because the goal is not to just run one container, but plenty of them, and you need some organization there. I hope that was relevant for everyone. I know it was a lot of information in not a lot of time.
Well, thanks a lot, Pierre, for being right on time. And so for those of you who want to wrap up now, we said we would do it in half an hour. We bam, smack, it's half an hour right now, so we did it. Thank you, Thank you, Pierre, for doing that. For those who want to stay a bit longer to have some more discussion and questions, feel free to stay. We're gonna answer some of the questions that have popped up. I'll go over the questions, Pierre, if that's okay with you, and then maybe some of them you can answer, maybe some of them I can answer. I'm gonna start at the top. Let's see. Yeah, it is possible to have diffs in notebooks with a tool called Jupyter NB Dime or something. Somebody mentions that, and there's also another notebook or another tool that somebody mentions called JupyText. And I know that is true, right? So there's a lot of tooling around notebooks that make you do better software engineering even in notebooks. And we encourage you to use them if you can, right? It's just, the reality is, what we see at least, is that they're often not enough and they're often not even used, right? So if you can do with them, great. If they help you get things to production, that's great. But we see a lot of companies hitting their limits with them as well. I don't know, Pierre, if you have anything to add to that.
No, same thinking. So like I said, like NBDev is also, from Jeremy Howard, is trying to address all of those pitfalls, and I think he's doing a great job. And if you watch his talk, he's explaining, he does everything in notebooks. Put code in production, writing the book about notebooks in notebooks, so it's really like notebook driven. No, so there are solutions for everything, but that's
another question, and I think I answered them. I want to check with you, Pierre. So do containers only work in Linux environments, no other operating system?
Well, so technically, yes, but in practice, for instance, I'm on a Mac and I just showed you that I'm using containers. How does that work? Here I have this, I'm not showing my screen so you don't see that, but I have Docker for Mac installed on my machine, and behind the scenes, they actually spawn a Linux virtual machine on my Mac. So I'm using Linux through my Mac. So, and they do the same on Windows. I'm less familiar with.
Yeah, did you have WSL2, and then you have something similar in Windows.
Something similar, right?
But when you deploy your containers, what we'll see in the next webinar, when you deploy them online in the cloud or somewhere, typically you deploy them on Linux hosts. That's the typical. I think Windows has some support, but well, we're not going there. Maybe. Yeah, so there's the JupyText thing. JupyText allows you to separate your code from your text, I guess. So if that's useful, definitely have a look into that. Julien also asked, like, do we have to use classes? Do we have to define classes, or is it just a good practice? Well, I think it's not a requirement, right? As long as you modularize your code, you structure it, it's fine. Python is definitely not an object-oriented language only. You can do object-oriented programming in Python, but I think 80% of people I know don't use that in Python. So,
the whole point of organizing your code is just that you can come back later and feel confident. You can come back, or anyone you share your code with is confident to touch your code and knowing, is he breaking anything or not, and still understand what was done. So,
indeed. Next question is about managing virtual environments and package dependencies, tools like Poetry. I use PyEnv a lot. I like that. There's quite a few of them out there. So whatever floats your boat is fine, I guess. I don't know, Pierre, if you have some recommendations there.
No, I'm actually not playing with a lot of those. I just stick with pip, very simple. I don't put any layer on top of that. Mainly because of containers, actually. Because then you don't fear polluting your local environment.
There was a good question from Sam. So, hey, what I'm missing is when you want to revisit the code for updating or debugging purposes, and you want to see the state between a couple of steps, you'll need to copy paste everything back into the notebook. So what are your thoughts on that, Pierre?
Yes, so indeed, so the goal here was to put in production. So in production, you're not supposed to debug in production, but I understand that things happen and you want to see what's happening. And indeed, there's no immediate solution to that. You can always run your code locally because you put it in a container, but it's also, you can run it locally and you can debug locally, right? But with containers, technically, it's possible to debug a container too by exposing some ports and so on. But
what I do can add is that if you have your code in libraries or in modules or in classes or whatever, you can import that code back into your notebooks and use that for debugging, right? So you only copy paste a little bit in the notebook, and then all the rest of the libraries you just import like you import pandas. And it's not ideal, but I think that's a good step to help you debug code without copy pasting. Yeah.
That's a very good point. That's actually why we also built notebooks in Datafy. That's because we already have the code of your project. And so by creating a notebook specifically for your project, then you have access to all your functions and all your dependencies. So your notebook, it becomes contextualized instead of just being an empty notebook.
Then Julien says, hey, am I correct in understanding that the packages don't have to be installed? Everything is encapsulated in the container. So, well, they are installed in the container, right? So they don't need a local install. When you do pip install in that Docker file, it installs your packages in the container, right? Sam asked a good question, is the code on GitHub? But maybe we should.
Yes, but it's not public
we'll follow up some, and we'll share a link to the code if you want to review that.
Yeah. Just gonna double check that I applied.
Is there any pattern to write a Docker file? I mean, which code write first and which code write last?
Yes. So the layering I explained, you should always think what are the things that are changing most often that you do constantly when you're developing, and those should come last because you don't want to rebuild your heavy first steps of installing your dependencies when you just change one character in your code. So globally speaking, to optimize a Docker file, you have to think about that. So what is changing the least and the most, and order them accordingly. And the other thing that we didn't touch upon is the size of your Docker file. So when you do things, you should make sure that you don't copy too much to your Docker file because that becomes a bloated image and container. So there are many techniques, and you can Google that.
Indeed. Walter has a good suggestion. He says, hey, I'm using keyring get password for my secrets and notebooks. Is that a good approach too? Yeah, well, maybe I want to add to that even more. What we like to do in production is use some kind of key vault, like it can be HashiCorp vault or AWS key vault, I forgot the name of the thing, where you don't pass the secrets as environment variables, but you just call them when you need the secrets. You do a request to that service, to that vault service to get the secret. And then your secret only, sorry.
We will most likely do that in the next part of the webinar, actually, because now it was a bit, showing you from the command line, I'm passing all my secrets. Of course, that's not what we want to do in production. In production, our container will interrogate some kind of secret manager.
Exactly. Your secrets should only live in one place and should be managed from there. And I guess the keyring get password does something similar. Ivo says the output lives in the container. How can I see it locally? Well, there we went a bit quick, but the output was actually written to an S3 bucket in the cloud. So it left your container, and then Pierre downloaded it to show it locally. That went very fast, but so you can just connect to, Go ahead.
So, two things. So a container, you can think of it just like a binary. So it's running and producing some outputs in terms of logs. And typically when you run a container, depending on where you run it, you can monitor the logs like I did in my console, right? I was seeing the log output. And in terms of what it produces about files, if you write local files in a container, then yes, you're correct. They're going to be lost after the container is finished. But in this case, I wrote to S3, which is,
all right. Cedric says super timing. So thank you, Cedric. Well, he has to jump, so he's not there anymore. Let's see. Thank you. I like it. Thanks all for saying thank you. Johannes says, hey, Chris, when we say packages are included in the container, do, as a developer, need to include them as artifacts, or pointing the version of the package is enough? Well, the mechanism we used there was the requirements.txt. There we define all the versions of each package. And then in the Docker file, well, if you rewatch the webinar, you'll see it. In the Docker file, we say pip install the requirements, and then it will take those binaries from the internet somewhere. So you do not have to have them locally installed.
Yeah. So assuming you have access to internet and to those package managers where you are building your Docker image, so building, not running, building, then this is the way. if you are in a restricted environment where you cannot access those, then you will have to put them down.
Cool. Thank you. Anita says, thanks for the introduction. It was good. How do you see tools like Metaflow and AWS SageMaker? So I don't know, Pierre, if you wanna go at that. Okay, so Metaflow.
No, I'll leave it to you.
Yeah, no, Metaflow, I don't know well enough to
I-
really form an opinion about. I know more or less what it does, but it's hard for me to form an opinion. AWS SageMaker is, well, the default notebook environment on AWS, I guess. For machine learning experiments, we often integrate with that at clients. So if you like to do machine learning experiments in SageMaker, that's good. But even, I want to say SageMaker is a lot more than the notebooks. What I like a lot about SageMaker is that it also has a very nice SDK, just a Python SDK, where you use for serverless training. SageMaker, when you look at the more advanced examples, they also use containers to do their training. They don't do all the training in the notebooks. The notebooks is just an interface for the training. So if you use the SageMaker notebooks for experimentation, I think that's great. When you industrialize your SageMaker code, I think even SageMaker itself recommends to just put it in a container and trigger it from there. What I like also about SageMaker, that on top of that, it also offers like a model repository. I think it even tracks your features now. It has a feature store, so it comes with a lot of these machine learning tools that you would typically like to have outside of just running your code. So yeah, I like SageMaker a lot. Yeah. It has its limitations, of course, but like any tool. Neil says, a small point on reproducible containers, even if you pin versions of your dependencies, there is no guarantee that your dependencies correctly pin the versions of their dependencies. So it is still possible to get a broken build if upstream made a mistake. Ooh, good question. Yeah, I guess you might be right. I don't encounter that a lot, to be honest, but yeah, you might be right. I think maybe where containers help, that once you've built your container, you also put that, we'll also see that in the next webinar, you put that in a container registry somewhere. And then you can first test it in a development environment. And then if you see that it works, you can reuse that same container without rebuilding it. You can just point to the same container in production. So that rebuilding issue that then all of a sudden things do break, if you use a container registry, that should also go away, I guess.
Yeah, so correct, Chris. So the point of Niels is also correct, but like you said, it's only impacting rebuilding your image and not running the container. So that's a good point about once you build an image, it's set in stone. You can run it anytime. But you're right that we also want reproducibility on building our image.
Then Jerome says, can you elaborate on the -e secrets that were passed when running the container? You need to check what is available from the services you use here, AWS S3, question mark.
So that's what we said, right? So in this case, it's a bit of a trivial example. I was like, let's not put secrets inside code, right? So I need to get the secrets from somewhere in my Docker container. The easiest way to do that is to expose that environment variables. But as we said in the next, like more seriously in production, we would use a secret manager somewhere or IAM roles, and we'll talk about that. And so we would not have to pass our secrets. But why did I do that? Is because my code in the container needs to access S3.
Indeed.
So I need to have some
make sure to rotate the credentials out. Yeah,
okay.
And then Oliver answers Niels a bit better than I did. So I guess Oliver is our Oliver. Oliver Legacy says transitive dependencies aren't necessarily pinned. There are solutions to that. Most familiar one is pip freeze. Since that logs all the installed versions of anything that's in your virtual environment, tools like Poetry and pipenv make this more human. Okay, so cool. Thanks for clarifying that, Oliver.
Yeah. And that is true in many languages. If you in JavaScript world, we also have the log files typically. So it's the same idea. You want to print in a file exhaustively all your dependency tree with the exact versions, and once it's there, it's captured completely. The only thing that can still break is if something is unpublished in the repository, then you can.
One final question from Sam, which is also a good question. Hey, if you have some higher level code which you use in your entire code base instead of solely in your Docker container, how do you manage that with a Docker build, as your higher level code will not be in the folder of your Docker file?
Okay, so that's a very good question. Many different ways to answer that. Depends on what this higher level code is. Typically, I would think of a library. So you build a Python library, you publish it somewhere. Either it's public or private. So in that case, you need a private PyPy repository or something. And then from your Docker file, you just install that as a dependency. That's one solution. Another solution is, as I said, images can be built on top of each other. So you could have a base image that already ships that code, and then you build another image that is starting from that one as a base layer. Just two of the many options.
For the insights. With that, I think there's about 30 people left of the 62 or something in the height of the webinar. So I think we can wrap up this session. Don't forget to subscribe to the next session. We'll send an email to you to get the link for the next session, or you can go to dataminer.be/webinars where you can find the next sessions. It was really fun for me to do this. Pierre, thanks a lot to do 99% of the work. And I'm looking forward to see you all in the next session. All right. Bye, guys.
Bye, everyone. Thanks for joining.